Hi there, and welcome to this presentation on social robots for independent living. And in this presentation, I will discuss a number of empirical studies that we've performed, and I've categorized them in three different themes. The first theme is navigation. It is important for a social robot to be able to navigate in a dynamic environment. The second theme is social cues. When we are interacting with social robots, it is very important that they have the right cues to give us the information we need at the right time. And finally, I will discuss a study on. There's a number of things that we think are important to take into account when we talk about a social robot navigating in a dynamic environment. And the first thing is personal space. Personal space is the area that we all have around us in which we don't want others to intrude. Unless those others are very dear to us, then we do allow them to get a bit closer. Now, if we have more people together in a room and they are having an interaction with each other, we're talking about a shared interaction space. This is essentially personal space, but a bit bigger because it spans over a group or two people. And when a robot or a social robot can take personal space and or shared interaction space into account, then this increases the comfort that we feel around this robot. In the personal space literature, we can see that there's a lot of different models or a lot of different theories of how this personal space looks like or what kind of shape personal space has. Originally, we were thinking that personal space was a circle that was around a person, and the circle had the same distance from our body, whether you went to the front or the back or the left or the right. Now, after that, some other researchers started to think that our personal space might actually be a bit bigger in the front compared to in the back. But other researchers started to argue for personal space being bigger behind us than compared to in front of us, because they see some people find it a bit uncomfortable when they are approached from the back. Now, other researchers think that personal space is more egg-shaped, so it's bigger in the front and back compared to how it is on the sides. And yet other researchers think that our dominant hand also plays a role. So for people who are right-handed, their personal space is most likely to be a bit bigger on their right-hand side than on their left-hand side. And for this, we created an experiment where we used a pepper robot, and we programmed this pepper robot to drive around a person at different distances. So the pepper robot was passing a person who was standing in the middle of the room on their front, on their back, on their left and on their right, in different directions. So going from front to back and from back to front, and from right to left and from left to right, at different distances. And after each passing behavior of the robot, we asked the person to indicate how comfortable they felt with this robot or with this specific trial. This is a picture from our lab environment where we have a participant standing in the middle of the space and a robot is just driving around. What we see here is very interesting. So what we did not expect was to find very big differences in how big personal space would be at the different angles. So when we modeled the perceived comfort at the four different, let's say, angles, a robot passing in front of you, behind you, on your left and on your right, we see that there's not very big differences between three of those angles, but there is a big difference with one of those. When the robot is passing people behind them, people feel a lot less comfortable. So when we make a curve of how comfortable people feel relative to the distance that the robot keeps from them, we see that they feel less comfortable if the robot is behind them. We used this result and we tried to model this in a kind of a heat map, like a heat map of how comfortable people feel at when the robot is passing them at different distances. And this heat map is looking as follows. What you see here is a little arrow in the middle of this picture. The arrow is pointing up. That means that the person is looking in that direction, right? Is looking to the top of the picture in this case. And here we clearly see that the comfort is lower behind the person, because the same comfort level takes a bigger distance behind the person compared to next to the person or in front of the person. Now, from this, we learned that passing a person from behind is perceived as less comfortable compared to passing a person from other sides. And when we really look at what was happening in this specific experiment, we noticed that when a robot was passing people from behind them, it was audible. They could hear the robot pass. Sometimes they could even feel the floor vibrate a bit when the robot passed, but they couldn't see it. And that really gave them this feeling of discomfort, right? So you feel something is passing behind you, you hear something is passing behind you, but you don't see it. And that is why people really expressed that there's a need to get some audiovisual feedback from this robot where it explains or where it shows what it is going to do. So people are informed about the behavior of the robot before it passes them on the back. And this brings us to the second theme that I would like to discuss in this presentation, namely social cues. Right? When people express a need for audiovisual cues, we can use social cues for this. Now we can distinguish between different types of social cues. And the first one is what we like to call implicit social cues. And these cues are often directional cues. So the robot could indicate where it is going while navigating in a room. And it does this whether or not a user is paying attention to the robot. So this robot could always be showing where it is going, such that if there's a person close to the robot, then that person should be informed where the robot is going at that point. The second category of social cues is what we call explicit cues. And these are really aimed at the user, right? Here the robot explicitly tries to show what it is going to do next in terms of its navigation behavior. Now, what we were interested in is whether showing these social cues has an effect on the emotion that people perceive in the robot. Because we're not just interested in people feeling comfortable when a robot is navigating, we also want to know what kind of emotions people perceive in the behavior of the robot. Now, when we want to study effects of perceived emotion, we first look into different theoretical models that exist that explain what kind of emotions people can perceive. And the most famous one is the model by Paul Ekman that describes 6 basic emotions that most people are able to recognize when looking at still images. Now, the problem with this model is that it tends to work very well for still images, but when we're talking about having an interaction with another robot, then of course this is a very dynamic system, dynamic context in which we study emotion. So then maybe this model doesn't apply so well. So instead we looked at Russell's circumplex model of affect, where he essentially frames all the emotions that we can have on 2 different axes. On the horizontal axis in the picture, you see valence reaching from unpleasant to pleasant. And emotions on the unpleasant side include being sad or being anxious, and emotions on the pleasant side include being happy and being elated. On the vertical axis, we see arousal, or in this case activation, going from a low activation or deactivation to a high activation, or what Russell calls activation. So in such a way, we can try to model emotions on these 2 different axes and see whether changing things in valence and arousal makes people perceive different emotions in the behavior of the robot. And we've done this in an experimental study. Let me show you what we did there. In this experiment, we again used a pepper robot, and we had this pepper robot drive in a fixed pattern around our lab. And the pepper robot was doing this with different speeds and with different what we call smoothness levels. So the pepper robot was either just driving very smoothly in circles, or it was just like stopping every few seconds, making it like a very rigid motion that the robot was showing. And we were interested in if the robot shows these different types of behavior, do people then attribute different emotions to this? Now, as I said, we looked at Russell's circumplex model of effects. So we asked people to indicate to what extent they found each behavior of the robot like negative or positive, ranging on a 5-point scale, or being very like deactivated or activated on the arousal level. And they could do this by indicating one of the pictures that you see. Now, when we look at the findings, what we did here was we looked at the average numbers of valence and arousal that people gave for different behaviors, and we also asked them, what emotion do you see in there? And then we gave them the list of emotions from Russell's emotion model, and then we tried to match or try to check whether the perceived valence and arousal was as expected with that emotion, if people classified the behavior as that emotion. And this is a heat map of all the trials that we ran in all of our participants, and what we see is that the most common answers are in the middle, right? So when we look at the valence ratings and arousal ratings, people basically average out their ratings towards the middle. And that makes perfect sense, given that we had different types of behaviors that should be in all the different parts of this heat map. Now, when we look at an emotion such as depressed, it's a negative emotion with a low valence and a low arousal. So we see a lot of values in the bottom left of this graph, right? There's a low valence and a low arousal, and that is also what people categorize as depressed. So when a robot is showing behavior that they see as having a low valence and a low arousal, they also attribute the emotion depressed to this. Now, on the other end of the spectrum, we had the emotion elated, being happy with a lot of arousal, essentially, and we see that this is scored a lot in the top right of this heat map. So we really see that people classify the emotions in a very similar way on this arousal and valence level as we would expect based on Russell's model. So what we see in this study is that the emotion that people perceive in the behavior of the robot varied over the trials. It varied over the behavior that the robot was showing. And the emotion that people perceive could really influence the way the people perceive the robot as a whole, right? If you see different types of emotions in different types of behavior, you could expect that when a robot is showing different behavior, it has a very different effect on how people interact with this robot and how they feel around the robot. Of course, we only looked at how people perceive an emotion in the behavior of a robot, and we think it is important to also look at a more personal connection. We think that people could really build a connection with social robot through its personality. So if it shows behavior or if it shows different types of cues that could differ for different types of personalities, then this could really make people create a connection with this robot. And studies that have been done by others show that the personality of the robot or the perceived personality of a robot could either match the personality of the user or it could complement, be kind of like the opposite of that of users. And some studies really show that matching the personality of the robot to that of the user is more successful, whereas other studies show that complementing the personality of the robot is more successful. When we really dive into the differences in this literature, we see that the effects that we find really differ between the roles that a robot could have. Now, we did this in an empirical study where we had a different type of social robot. So this is a social robot that was driving around. It has like little arms that could move around, and we had a face on which we could project like emotional expressions. We made this robot be perceived as a robot that is introvert. So it was like kind of like a bit in itself, and it wasn't very outspoken, and it didn't move so much, and we used very neutral colors in the face. Or an extrovert robot, where the robot was much more moving, showing much more enthusiasm, like having a different content of the sentences to put like a bit more flair in there, and also the expressions that we used were a bit more bright in its face. And we give the robot two different roles. The first role was that the robot was a service robot. So the robot was just there to remind people to take their medication, or to remind people to do their exercises, or maybe to do an exercise with them together. And the other role we gave the robot was an entertainment role. And in this role, people could play a game with the robot. And this was either a word game, or we had different types of games there as well. Now, we were interested in, are there differences in people's preference for an introvert versus an extrovert robot compared to their own personality? Now, just when we wanted to start running this study, lockdown happened in our country, so we couldn't collect the data, as much data as we would have wanted to collect. We did collect a bit of data, and this data shows the following. It really shows that there is a potential interaction between the role that the robot has and the type of personality that we show there. So it could really be that there is something in there. However, we had too limited data to draw valid conclusions. So of course we want to like redo this study when things are a bit more open again in the future, but we absolutely think that there might be something in there. So we're currently planning our future studies to dive deeper into this, and hopefully in let's say a year from now, we can like publish some literature showing that there's actually like an effect of like the type of role that a robot has and what personality it should be given to be more likely to be accepted by users. That's all I had to tell you today. I hope you enjoyed this presentation, and I will be around to answer any of your questions. Thanks.